of Ideatec softwares and Ideatec automation. And I'm here in partner with CII for ACE 2020 program for real-time monitoring, asset management, and IoT automation. And now my scope of this presentation is IoT-based real-time monitoring and asset management. Yeah. Now, a short introduction about Ideatec. It's an wholly Indian company. We are in customer service since 1997, and we have about 2,000 plus clients in total. We are developer, manufacturer, and service provider since inception. It means that we develop and deliver solutions, and it's like a marriage with all our customers. We continue our service till date. We are into real-time monitoring since 2010, and we have acquired about 600 plus clients. And we are into process automation since 2014 and have acquired about 1,000 plus clients, 100 plus clients. And we are into Internet of Things, IoT, since 2018, and we have about 20 plus clients. And we are delivering real-time service for about 12,000 plus devices as on date. Our USP is, number one, we integrate all existing devices. It means that any factory will have some of the other devices, even for your manual visual monitoring. We integrate all existing devices. That's point number one. And we can deliver end-to-end solution. Sensors to measure the parameter at any point of a machine or a plant. The instrumentation, which is the display part of the sensor and electronic part of the sensor. The communication. The most hidden and most important is communication, because in any corner of your plant there might be a device, but we need to see it on a computer. So we can establish wired, wireless, and mobile technology communication with the right choice or with the mix of the right choice for any factory or establishment. The cloud services, which includes server storage and software, the mobile app part of the software, and artificial intelligence built on the data of the data being acquired. So we provide end-to-end solution. So this is the biggest USP. Our solution range are real-time monitoring of quantitative parameters: water, energy, steam, air. What do you mean by quantitative parameters? When you take temperature or pressure, it is all instant value. At this point of time, what is temperature? At this point of time, what is the pressure? But when in case of a water, energy, or steam, air, etc., it is a quantitative. Flow is only the qualitative or the instant parameter, whereas the cumulative value of water being utilized, consumed, the energy being sent, steam being consumed, etc., these are all quantitative parameter. Out of the quantitative parameter, we derive the periodical value by a simple formula, closing minus opening. So that is why it is called as quantitative parameter. And the others like temperature, pressure, vibration, flow, pH, TDS, and current, voltage, power factor, frequency, etc. are called as qualitative parameters. We provide water accountability software. It is much more than monitoring. We monitor water, we account it, and we give a water balance, and we give the complete accountability of the water. It is like a cash balance. What you received, what you utilized, what is the balance? If you are accountable in such a fashion, it means that all the water data, water you have, what you acquire is all reliable. The other one is the energy management and energy efficiency monitoring. In terms of energy, the quality parameters are huge in numbers. A minute monitoring is even not enough, because all energy quality related events happen in the milliseconds, that is between the seconds. So we provide energy management, and in terms of efficiency monitoring, it is a machine consumption versus before an upgradation, after upgradation, before a process design, after a process design, etc. So we provide energy management and efficiency monitoring. Process automation. In wherever the place there can be, since we are monitoring n number of parameters, we can give this as the feedback to your control system, or we can even provide a control system which will convert the system into a process automation. And wherever there are variable parameters available like pressure to flow, etc., the process automation will help a lot in efficiency monitoring. Because energy efficiency is not just by having rated power devices, it is also in the process. A process automation helps a lot in terms of energy efficiency. Asset management. Once we consider all these monitoring systems and all our large electrical installation, etc., becomes which are being an asset can be managed using these software. Computerized maintenance management system. Eventually, the maintenance is the biggest work being done and a continuous work being done in a factory. And now, with all IoT, there is another concept come up, is the predictive maintenance. Maintenance after failure is reactive. Maintenance before failure or before anything in terms of a periodic maintenance means you need to care about all devices irrespective of its status. But the case of predictive maintenance is something like you attend the device which is going to fail in near future. So computerized maintenance management, these are all the set of our solutions being delivered. Now I have taken a case study arrived out of our monitoring system, a simple but an effective case study which shows like why monitoring, how monitoring can help us to get the root cause and how to avoid. This is about two identical UPS system where you are seeing a current trend graph. The blue line is one UPS current trend graph and the yellow line is the other UPS current trend graph. You can eventually see that there is a difference between the both the trends, the blue line and yellow line. If you feel that what is there, the equipment is operating normally, everything is normal, only the graph, the oscillation might be of many reasons. There is one good reason why we need to take care of such things. I will tell you why. There had been a failure in that yellow device, yellow graphed device, and eventually after the correction, this is the trend being generated, the yellow and the blue. Now this both looks normal. In between, what happened? The damages are breakdown for 10 days, multiple component failure, and cost escalation 3 times. So this is not earning, but certainly this is saving. Any such monitoring system, even though the first step of such monitoring system is to avoid unwanted breakdown and cost. So now you see like how does it is worth having such system and having alert on such variations. The yellow line, at this point, it is well known that the equipment is working properly. There is no attention given to it. But once after a failure and after a correction taking a graph, it eventually shows that a real-time monitoring. This you cannot do by taking a reading daily once, etc. This is possible only by a continuous and real-time monitoring so that the system can give you alert and avoid these damages. The next important facility is utility costing. It is very clear that the monitoring can save in that way. In day-to-day operation, every factory does costing in one or the other manner. Utility costing, product costing, etc. How such real-time monitoring systems can help you take better costing? See here, this is a boiler. We are trying to generate the cost of steam generated. What are the parameters being considered? The run hours, firewood consumption or any fuel like coal consumption, electricity consumption, steam generated. Out of this, now we derive like what is the firewood consumption, fuel consumption per hour, electricity consumption per hour, steam generated per hour, cost of firewood, cost of electricity, cost of chemicals, and maintenance cost. Our software has got both capability of acquiring the real-time data through devices like run-hour meter, energy meter, steam flow meter, etc. And also has got a capability of giving input of parameters like firewood consumption, where the weighing are all manual, maintenance cost taken from the maintenance department due to any breakdown, any chemical utilization, etc. These are added to it, and a total cost is arrived, and cost per steam can be arrived just with a click of a button. So almost, except, excuse me, except the firewood consumption, all other parameters are acquired by the instrumentation and monitoring system in a real-time basis, and this can generate you a date-wise figure, a summarized month figure, or a year figure. With these things, you can know, like, if there is any deviation in your costing, where is the deviation, how to tackle it. This makes the life of the maintenance people very much, and it gives the result for the factory with a high amplitude. Here is another case study of decision making. I want to say a decision making the right way. Again, I have taken two identical UPS, in which one UPS having one set of battery is consuming less current over the other UPS having another set of battery. Generally, when such a problem happened, and when a person analyzes, eventually they take care, like the battery, they test the battery, they test the acidity or the battery, and they say, like, battery is end of life, so it is better to change the battery. There was a question like, why not the UPS? Why not the UPS could be a problem? Okay, how to test? Let us interchange the batteries between the UPS, and let us observe for next week time. Once we did that, there was an interesting result. What is it? The battery which expected to perform good with the other UPS, it started drawing more current. Whereas the battery which is set to be an end of life, with another UPS, it performed fair. Now, where is the problem? What should be changed? Certainly, it is the UPS. Once the UPS is changed, now you see the current figure, both the set of batteries, now with these UPS, draw the same current, and now you tell, like, what is the right decision? Eventually, now taking into the cost factor, the battery was costing about 1 lakh, and the UPS was costing about 0.5 lakh. The savings is already, without betting on the battery, it is 0.5 lakh saved. And eventually, after changing the battery, once we know, like, still the UPS is not performing, additional another 0.5 lakh. So almost 100% of the expenditure which was expected was saved. And that is what I want to say, decision making in the right way. Now, coming into Internet of Things. What is Internet of Things? It is a new jargon. Everyone feels like it is something different. So I want to flatten the thinking. It is nothing but network of physical objects that are embedded with sensors, communication, and software. In simple, if I want to say something, take the water heater in your washroom. How you switch on? You go to your washroom, switch on the, you have a switch to switch on. And if you want to control your temperature, nowadays almost all heaters, geysers has got the thermostat. You turn on the thermostat. During summer, you keep it low. During winter, you keep it high. So now this is the way your geyser get operated, a water heater get operated. Now you just consider the water heater is added with facility so that you know in your mobile what is its temperature. You can switch on the geyser at any point of time. You start from your office, before 10 minutes you enter your house, you switch on your geyser, it is on, you have the right temperature, you consume the hot water, you switch off, your energy is being saved. You can set temperature, you can switch on, you can switch off. Moreover, now you can think about, if you are scheduling morning 8 o'clock, you are going to take bath daily, you want to switch it on by 7:30 and switch off in another 15 minutes. For evening, you can schedule your on-off time, and you know how many hours the equipment had run, and this is what we call adding smartness. So any equipment added a smartness, it becomes an IoT enabled. And such enabling IoT is not just to operate, it is also to monitor the energy parameters, to monitor the mechanical parameters, and it is also to monitor the quality at different stages. Sewage is done for a particular treatment plant. It is to monitor the process parameter at different stages. More importantly, it works round the clock. For each of the device, it is being attached dedicatedly. Now, one such device in our product profile is this device. The features are, it has got an integrated energy monitoring with 8 inputs to monitor 8 status, 2 analog inputs which can take vibration, temperature, pressure, what is relevant to the machine, 1 digital counter which can count on the rotations, RS-485 input to add external devices for data acquisition, biometric interface to capture who is the operator in case of a process line, what is the operation or the job being operated, a 16 keypads to have some selections, monochrome graphic display to display the status of the process, relay output which can be programmable or remote control so that you can, from anywhere you can switch off the device, or an artificial intelligence system can switch off the device during adverse conditions, and communication using Wi-Fi or GSM or LoRa, which is chosen based on the location of the installation and which is wall mountable and IP65 protection. It means that you can fix it anywhere. The second line of device is an economical one with 4 analog input, 3 digital input, 1 pulse as a counter, an RS-485 or RS-232 external communication reading, GSM only communication, data communication protocol of HTTP, MQTT, and FTP so that we can push data simultaneously to more than one server, over the air firmware upgrade, making the maintenance cost simpler, built-in RTC, 2 digital output programmable, and it is DIN mountable, which we can put it in a panel. Where such IoT deployment are useful. You take a large factory which has got a distributed process, wiring cannot be done, need not be done. Such IoT devices can be fitted to each of the equipment independently, and it will acquire data and push to the cloud simultaneously. What it does, it captures energy parameters, voltage, current, frequency, power factor, reactive power, active power, etc. Mechanical parameters like vibration, temperature, RPM, torque, lubrication, insulation, etc. And it has been put on a map on different locations. The green says it is proper, blue says it is not functioning, red says there is a problem. Now you know where to attend, and maintenance guy at any point of time can know like where to attend, what to attend. The benefits are implementation of predictive maintenance. This is the new jargon. Optimizes the maintenance operation. You need not run to all machines which is okay, which is not okay. So it optimizes the maintenance operation. Effective production process. When there is no breakdown, certainly the production process is going to be effective. Continuous achievement of results, which is the key for an industry to be successful. Energy efficiency. In the case studies, we have shown you how to take decisions and how to improve energy, and increase in lifespan of the equipment. Once the equipments are properly maintained and utilized, certainly the lifespan increase is guaranteed. Increase in health and safety of manpower. This is an internal unknown benefit. There could be a lot of sufferings in manpower due to health hazard of equipments in terms of electricity, etc. Increase in healthy and safety, and it gives the path for artificial intelligence. Artificial intelligence is not, it cannot just stand alone. It needs a lot of data. This kind of solution devices capture a lot of data, store, and adding more control factors to it. That gives the start for applying artificial intelligence. Minimum 3 months data is required to get an effective result out of any device or installation or a plant section. So this gives the path for artificial intelligence.